So welcome, my little pre-calc babies, to our first online video, first online lecture, and I will be doing my best under these scenarios. I normally, you guys know, I never teach online. I normally teach face-to-face so I can see your little faces, but that is not an option, and the game must continue. So here we are. Now, at this stage, we are in Chapter 6 of the course, and the topic of today is the law of sines. So let me see if I can paint you a picture of where we got to go from here. So notice I have two triangles within inscribed within this circle, right? The blue triangle, the red triangle. Now, the blue triangle is a right triangle. It has a 90-degree angle, and the first part of the course up to the midterm, chapters 4, chapters 5, it was all about right triangle trigonometry, right? Everything assumed a right triangle. Now, what we want to do now in chapter 6.1, 6.2 is we want to venture into non-right triangles. For example, if we look at the red triangle, this is clearly not a 90-degree right triangle. So the question is, are we stuck? I mean, can we, all that we learned about sines, cosines, tangents, can we still apply them? And if so, how so? And how can we go about continuing our study in trigonometry? So let me start with how we label. So I'm going to be focusing on the red triangle for right now. And the way that we label a triangle, so if you think about a triangle, it's going to have 3 angles and 3 sides. And just traditionally, if you can kind of notice off to the right over here for triangle ABC, traditionally what we do is we let uppercase letters, uppercase A, uppercase B, we use those to represent the angles. So I'm just going to draw angle A, angle B, angle C, and then we use lowercase letters to represent the lengths of the sides. So now, side A is always going to be directly opposite of angle A, right? So if I have angle A here, then I'm going to have side A here. If I have angle C at this point, that would mean opposite of that. This would be side C, and this would be side B. Okay. So now, where do we go from here? So I want to go ahead and say a couple quick things, and then we're going to see how this blue triangle and this red triangle, how we can relate them. So first, let me give this a name. So non-right triangles are called oblique. Okay, so if you hear me say oblique triangle, what I mean is a non-right triangle. Now, many of the pictures that you're going to see in these slides here are located at my website, my first name, last name.com, jeremiahdike.com. You would just click courses, and then you would find PreCalc 2 or Calc 1 or whatever course that you decide that whatever course that you would be in that you decide that you need to get these slides. Now, so you guys would be in PreCalc 2. All right, well, let us get back to our geometric look at the law of sines. So what we can say, and I don't want to spend a whole lot of time on some of these preliminaries, but notice that I'm marking, I am going to go ahead and label the blue side, all the angles on the blue side as well. But I want to notice that the angle that's being made, let's just call this D, right? So we have triangle ABC and we have triangle DAB. And now what I was pointing out is the angle of D, so angle, what the heck was that? Try that again. So angle D is congruent to angle C. All right, and now I could go into the geometrical reasons of why when you have a triangle inscribed within a semicircle where one of the sides goes through the center of the circle O, I could kind of go into the why it intercepts the same arc length. But if you will just allow me, to say that angle D is congruent to angle C, then that would mean, of course, that sine of angle D is congruent to sine of angle C. All right, so a couple statements out of the way, and now I'm going to get us to where we need to be. So if we take a look at, if we're just thinking about the definition of sine, right? We're going to look at the sine of angle D. Well, by definition, sine is the opposite over the hypotenuse. But let's do a little bit better than this. So sine of D. All right, ready? Let's find angle D, and then let's find the side opposite of angle D. Well, hopefully you're noticing this. So I got opposite of angle D is side C. So I have C over, now what is the hypotenuse? All right, well, let's you and I agree that the hypotenuse of this blue triangle, the hypotenuse of this blue triangle is basically the diameter of the circle, right? So the hypotenuse of, remember, we're dealing with the hypotenuse of this right triangle, triangle DAB, is the diameter of the circle, right? Which is, so 2r, two radiuses. I hope that makes sense. I mean, I have a radius here, I have a radius here. So the hypotenuse is the diameter, or 2 radiuses. Okay, and now here is where it all falls into place. So everything that I've said up to this point is old news, right? We knew how to find sine of right triangles, but because of this statement right here, because the fact that angle D is congruent to angle C, and that sine D is congruent to sine of C, then what that means is that sine of C is also equal to C divided by 2r. Ready? Now, if I take sine of C, which is equal to C divided by 2r, and I solve it, if I solve it for the hypotenuse, this would mean that 2r is equal to C over sine of C. And we're almost done. I can just chat you through the rest of it, okay? So I can do that. Remember, we left off, on that previous slide, we left off with the statement that 2r is equal to C over sine of C. And now I can do that same congruency for angle B and for angle A, right? I could go through the same steps, and I would end up with B over sine of B is equal to 2r, and A over sine of A is equal to 2r. And now all I ask is that you see how they went from what I wrote on at the top of this page to this law of sines, right? So if clearly 2r is equal to 2r, so I can make the statement that C over sine of C is equal to B over sine of B is equal to A over sine of A. And that is, in essence, the law of sines. So let's go ahead and review a quick topic out of probably out of middle school mathematics, the idea of proportions. Because we're going to use this law of sines equation, right? And we're going to be setting it up in proportions in order to solve. So now be careful because you're not in class. I can't make eye contact with you, right? So you are going to have so many distractions just right there beside you. Your phones, your computer. You have 10 tabs open at the same time. You're watching a YouTube video and who knows what else, right? But be careful. Come back to me. All right. So when we say a proportion, right, what we mean is, so we have a fraction set equal to another fraction. Now, the way this game works, right, for any proportion, let's think of it like there's 4 parts. Okay? Now, in this example that I have x over 7 is equal to 50 over 350. And what I need you to notice is that I have given you 3 of the 4 parts. Now that's perfect. If I can give you 3 of the 4 parts, then you can solve for the 4th part. Ready? So let's go ahead and do that really quickly. So if you want to solve this equation for x, let me show you the quickest way of doing it. I like to just cross multiply. So we're going to do 50 times 7, and we're going to do x times 350. Ready? So 50 times 7, I believe, is 350. And x times 350 is 350x. And now I can solve for x. Notice the setup. So we need, in order to solve a proportion, we need 3 of the 4 sides. Now likewise, in order to solve a triangle, we're going to be making use of the law of sines. And a lot of what we're going to do is going to look exactly like that proportion problem. So what is the law of sines? When do we use it? So let's go through this quickly. So when should I use the law of sines? Well, clearly if you have a right triangle, you don't need the law of sines. We can approach it the way we've been training so far. But the first scenario where you may need to use the law of sines is if your triangle takes on the form of what we call ASA, or angle side angle. In other words, what that means is they give you 2 angles, and they give you 1 included side. Okay? Angle, side, angle. Notice the S is nestled between the 2 A's, right? So angle, side, angle. You have 2 angles and then 1 side in between. So what would that look like? Let's use this blue triangle here. So what if I'm just going to make up something? Let's say that, I don't know, that A is 60 degrees, and we'll say that B is 50 degrees, and we will say that, remember, it's angle, side, angle, so the side between those 2 angles would be side C, and we'll make up something. We'll say it has a length of 10. Ready? So let's draw that out. So I'd have 60 degrees here, I'd have 50 degrees here, and I'd have a length of 10 here. All right, now, are you with me? So this triangle is an angle side angle triangle. Okay, so the question I would have if I'm in your in your chairs. Okay, well, what is it that you're going to ask me to do? Well, first I have to give you information, right? So what you're looking at, this blue triangle, is what I would give you. And then what I would need from you is for you to be able to tell me what side A is, what side B is, and what angle C is. Are you with me? If you have all three sides and all three angles of a triangle, then you have solved the triangle. Ready? Let's go to another case, right? We'll come back and use the law of sines in just a second. But another scenario when you would need to use the law of sines would be if you have an angle side, right? And in this case, what are you given? Well, you're still given two angles. But this time you're given a non-included side. Okay, so let's just make up something. Let's just say that A is 60 degrees again, B is 50 degrees again. But this time you don't have an included, you have a non-included side. So it might be something like little a is 12. Okay, so let me draw that out. So we have A is 60 degrees, B is 50 degrees, and now little a is equal to 12. So if you just take a look at the blue triangle, this again would be what I give you. I would give you an angle side with this triangle with this information. And then what would I ask of you? Well, I would ask you to tell me what the length of side C is, what the length of side B is, and what the angle C is, right? Once you have all that information, then you have all 6 parts of a triangle. You have solved the triangle. Now, the last type of triangle where you would need to use the law of sines is what we call a side-side angle. Okay, and in this case, let me go ahead and write it out. So in this case, a side-side angle, you would have 2 sides and a non-included angle. All right, now, here in just a second, we're going to try an angle side angle and an angle side. And I honestly, even if you were really struggled through the first half of this semester, I think you'll actually agree with me that law of sines is pretty darn easy. Okay, and so I'll show you that in just a second. But what I want to go ahead and say for right now is if you have a scenario where you have a side angle, then you need to slow down, because this last situation is the toughest problem that I can give you, right? It's actually called the ambiguous case for the law of sines, and we're going to come back to it probably in the part B of this video. But for right now, let's jump in. Let's start using the law of sines. Ready? So let's do this. Let's have a playbook, a recipe for how we're gonna do this. Okay. So notice example 1. It says solve triangle ABC if, and here we go, you're given angle A, angle B, and little b. Okay. Now here's my suggestion. Until you get good at this. Now hold on for a second. Where are all my pictures? There we go. So until you get good at this, your best bet is to always start by just drawing a random triangle. Okay? So notice what I said is you're trying to solve some triangle ABC, You don't know if it's side angle, angle side angle, all that stuff. My suggestion is your first step, step one, just draw some generic triangle. Note it, like, don't give it any thought. Just draw a triangle, label A, B, C, little a, little b, little c, and let's fill in what we know. Ready? So in this case, we would know that angle A is 33 degrees. Angle B is 105 degrees. And little b is 37.9. Okay, I'm not going to care, and I don't think you should care too much as to whether your triangle really represents what the true triangle of this should look like. I'm just suggesting draw some random non-right triangle and label it. Okay, that's step one. Now, step two, now this is my personal preference. I want to know how I get all my points, right? So what is the professor asking of me? Well, in this case, the professor gives you 3 pieces of information about the triangle, and then your professor is asking you to find out what angle C is, what I'm going to put this is an angle symbol here, what side C is, as well as what the length of side A is, right? So I'm labeling everything that I need to get all my points. And now it's time to jump in and start using the law of sines. Okay, so let's start with the fact that you have 2 of the 3 angles of a triangle, correct? So if you want to find angle C, you don't need the law of sines at all to find angle C, right? Because you already know that the sum of angles for any triangle is going to equal 180 degrees, right? So for angle C, if we just take 180 degrees, I know all 3 angles have to add up to be 180 degrees. So if we just take 180 degrees and we subtract out 33 degrees, then subtract 105 degrees, whatever's left is that angle. So in this case, angle C is going to be equal to 42 degrees. Okay, and now I'm going to go ahead and write that here, 42 degrees. And furthermore, I'm going to go ahead and label it on my triangle, 42 degrees, because I might use it later on. I might use that little piece of information. So 42 degrees. Okay, so now think of it like you've already gotten 1/3 of your points. How's that? And now let's see if we can figure out what side A or side C is. Okay. So if you recall, and I'm gonna kind of, you'll stay with me for just a second. I'm gonna scroll back and I'm gonna grab that formula for the law of sines, just so you have it right there in front of you. Let's see if I can bear with me here. All right. So I'm just going to kind of park this. Let's just park it here for now. And let's see how we're going to set this up. All right, so we want to try to figure out side A or side C. Doesn't matter which one you choose for right now. Let's assume that what we want is side A. Okay, so now that was arbitrary, but you have chosen that you want to find side A. So how are you going to do it? All right, well, the way that we're going to make this work is clearly you're going to need A over sine of A. Remember that proportion problem, right? Where you have a fraction set equal to another fraction. but you better have 3 of the 4 parts, right, to make it work. So since I want to solve for side A, I'm going to have A over sine of A. And now at this stage, let's think about how I have to set it equal to something. So I could set it equal to B over sine of B. B over sine of B. Pause for just a second and make sure, do I have 3 of the 4 parts? Well, do I have side B? Yes, I do. Do I have angle B? Yes, I do. Do I have angle A? Yes, I do. So I have 3 of the 4 parts. So this works perfectly. Now, if for some reason that when you're doing your setup, if you didn't have 3 of the 4 parts, then just go back and pick C over sine of C, okay? But as of right now, let's just plug in some information. So this means now I'm going to plug in. So I have A over sine of, well, A is 33 degrees. And that's going to be equal to, give me 1 second. So B, in this case, is 37.9. And angle B is 105 degrees. Okay, are you with me? Are you with me that we have put everything in the right spot? And now, just like in the previous algebraic problem you solve for x, we're going to do the same thing, and we're going to solve for a. So let's cross multiply. So 37.9 times sine of 33 degrees. That's going to be equal to, now let's cross multiply again, so that's a multiplied by sine of 105 degrees. All right, so hopefully you're anticipating where I'm going to go next. I still don't have a by itself, but if I divide the right side by sine of 105 degrees, that would allow me to solve for a. I just have to be willing to compensate by dividing the left side by sine of 105 degrees. Ready? All right. So let me get you to your answer, and then let me give you just a piece of advice along the way. So a is going to be equal to 37.9 multiplied by sine of 33 degrees divided by sine of 105 degrees. All right, now here's the good news. So if the first half of the class, almost universally, everything had to be in exact answers, right? That you weren't allowed to round, right? So if the answer was pi over 2, you had to write pi over 2. You weren't allowed to approximate. But now I'm going to allow you to start rounding. So at this stage, you can grab your calculator, make sure it's in degrees, and you can do 37.9 times sine of 33 degrees divided by sine of 105 degrees, and then you can approximate your answer. So I go out to 2 decimal places. 21.37 is the side length of A. Okay, so let me go ahead and write that. So A is 21.37. All right, and I'm going to go ahead and label it here. So A is 21.37. Now, why am I labeling it in so many places? Well, first off, you got to think of it as it's your job, right? It's the job. If I am your client, it is your job to give me the product, right? It's not the client's job to hunt through your work and try to find the product that he or she paid you for. So I want you. The product is angle C, side C, side A. So please make sure you circle or box in or tell me what it is that your answer is, what your proposed solution is, because don't leave me to have to hunt through your work to try to find it, right? So, all right, let's now finish this guy up. So the last piece of information that we need is side C. So I'm going to my law of sines. I'm going to go ahead and pick C over sine of C. And it does not matter. This is hard for a lot of students, right? Because they really want the recipe. You put this much and that you follow the directions perfectly. But it does not matter if you can put A over sine of A or B over sine of B, because you have all the other information. So it's arbitrary. Now, I'm just going to use B over sine of B again. Okay, so I'm going to start to speed up this process a little bit, especially on the next problem. But as of right now, let's plug in the information that we know. Ready? So little c, we don't know that yet, over sine of c, and c is, I believe it was 42 degrees. Yep. And that's equal to b, which is 37.9. over sine of b, which is sine of 105 degrees. All right, so hopefully at this point you're anticipating where I'm going with this. We cross multiply. It's almost always going to be cross multiply divide, cross multiply divide. So henceforward, I'm going to go ahead and get us to this step right here. But for this problem, just so that you have some good notes, I'll go ahead and do it in order, just like I did the previous one. So if I cross multiply 37.9 multiplied by sine of 42 degrees is equal to little c multiplied by sine of 105 degrees. Okay, so dividing both sides by sine of 105 degrees. We now can get to our results, so that's going to be length C is 37.9 times sine of 42 degrees divided by sine of 105 degrees. Okay? Or in other words, C is equal to or roughly equal to 27. By the way, we are going to do this in real time. I'm not going to edit. I should say real time, but I'm going to continue, no matter if my two boys walk in and start asking me questions about a video game, or my wife walks in and tells me I need to do the dishes, or whatever it is. We are going to keep rolling. Got it? So no matter what happens. So little c in this case is roughly equal to 26.25, and now you have solved the triangle. You have all the information. So not bad, right? Not bad. Okay, so let me give you one piece of precaution, and this is something you should pay attention to. So remember, at this stage of the game, it's going to be okay to have some decimals. It's going to be okay for you to round. But think about it for a second. Especially for my students that are in this class that are going into some type of STEM major, right? Some type of science, tech, engineering, or if I can coerce you into maybe even mathematics, right? The idea, we want to take pride in our work. So if you round right here, then you round here, then you round at the end, do you see how every time you round, you are compiling your margin of error? So you're getting farther and farther from the true solution. So what is the suggestion? The suggestion is wait till you get to this step right here. Then round. Round one time. Round at the end. Okay? You don't want to fire an arrow if you've just been rounding multiple times throughout the calculation of its trajectory, right? Even if you're off by 1 degree in your calculations, over time that margin of error is going to be enormous, right? You over long distances, you're going to miss your target by quite a lot. So let's try another one, and then we'll probably go ahead and stop this video and let this be part A. Ready? So notice how all the questions look the same. Solve triangle ABC if, and here we go, A is 50 degrees, C is 33.5 degrees, B is 76. My suggestion still stands. Draw a triangle until you get until you get good at this stuff, okay? Until you really get good at this stuff, just draw a triangle. It'll keep your work neat, and then label what you have. So we know that this is, angle A is 50 degrees. Let's see here. Angle C is 33.5 degrees. And side B is equal to 76. All right, so what type of triangle is this? Well, this is an angle side angle, right? You have a side included between two angles. All right, so do you remember step 2? Step 2, for me at least, is always to list out the information that is required of me, right? What do they want of me? Well, they want angle B, they want side A, and they want side C. Okay. So let's go through this a little bit quicker this time. So angle B, that's going to be, remember how to do that, angle B. So just take 180 degrees. That's how much all three angles in that triangle should add up to be, and then subtract out the angles that you already have. So minus 50 degrees, minus 33.5 degrees. Therefore, angle B, I equal to 96.5 degrees. Hopefully, if you see any silly mistakes, normally I'm quite willing to make silly mistakes because I always have you there to tell me I just made a silly mistake. But now I will, if I make a silly mistake, I might not even notice it. So we have 4 of the 6 parts of a triangle. Now it's time to jump in. You should, if you wanted to, you could always pause the video right now and you could try using the law of sines. Right, I'm going to go ahead and bring back in that law of sines just so we have it as a reference. But let's go ahead and jump in. So notice, let's assume that you want side C. So you definitely want C over sine of C. Right, now do me a favor. I'm going to make a mistake, right? So I'm gonna change the color. I'll change it to red, right? Because normally people with red pens are the ones that are telling you that you've made mistakes. So bear with me. Let me make a mistake for a second. So hold off if you're taking notes. And let me write it, and then let's see if you can see why this would be a mistake. All right. So I want side C. So I'm going to take C over sine of C. And then I need another fraction to set it equal to. So I'm just going to choose A over sine of A. Right, so let's do some uncomfortable silence for just a second. Why is that a bad choice? Okay, well, let's see if you can, do I have angle A? Yes, I do. Do I have angle C? Good, I do. Do I have side C? No, but that's what I'm looking for. Do I have side A? No. See, I only have 2 of the 4 parts. That's not going to work. That's not going to work for us. So let me go ahead and erase that. So a better choice would be C over sine of C is equal to B over sine of B. All right, so the way this is going to work for the remainder of this problem is I'm going to plug everything in, and then I'm going to jump to that step where I've solved for C. Okay, that's just that little algebraic step. Okay, so let's do that. So C is over sine of equal to B over sine of, and let's put everything in the right spot. So sine of C, all right, so I have little is C, a big angle C is 33.5 degrees. And then little b, in this case, is 76. And angle B is 96.5 degrees. Okay. So at this stage, I'm going to solve for little c. I'm going to solve for side C. So C is equal to 76 times sine of 33.5 degrees over sine of 96.5 degrees. Okay, I have not rounded at this point, right? That, what I just boxed in is the true answer. Okay, that is the actual length of C. It's only at this point where we allow for some margin of error, and we say that C is, well, we can say is roughly equal to 42.2. All right, one more round of law of sine. So now I want A, side A, so I'm going to choose A over sine of A, but that little mistake that I was talking about earlier is no longer as meaningful, because now I do have little c and big C, and I do have little b and big B. So I'm going to go ahead and choose B over sine of B. Maybe I should pause. Why do you think I chose B over sine of B when it was optional? Well, we know that side B is 76, right? That was given to us. And we know that angle B is 96.5 degrees. But we approximated C, right? So if I really, really, truly cared about being as close as possible in my margins, then it's better to choose B over sine of B, because I actually know, without rounding, angle B, little b, as well as big B, right? But since I'm allowing for rounding errors, it would have been okay if you would have chose C over sine of C. Right, what am I going to do now? I'm just going to plug everything in. So I have A over sine of, let's put everything in the right spot. So in this case, angle A is 50 degrees. B is, of course, 76. And angle B is 96.5 degrees. Okay, so now we solve for A. A is equal to 76 times sine of 50 degrees divided by sine of 96.5 degrees. All right, and what is it? What is it, the result? So A is roughly, always check my math, make sure I'm okay here, but roughly 58.6. Voila, we're done. All right, so we're going to conclude. We're going to let that be part A. When we come back, we're going to learn about this, well, this hard case where where we have what we call the ambiguous case for the law of sines, and we'll get back to that in just a second in part B. See you soon.